So currently in Chapter 3 in AP Stat, but we're kind of encompassing more than just that. Chapters 1, 2, 3, some of 4 and 5 as well. We're kind of hitting on a whole bunch of stuff, but we were working on frequency distributions and cumulative distributions, the idea of parameters go with population and statistics go with samples. And now we're working on histograms and how to use our calculators for them. And if you remember, before we left, I gave you all this. And trying to figure it all out with the TI calculator. Basically, you got to turn the stat plot on, which was the second y equals to kind of turn that on. So you make sure that's on. Here is the histogram thing that you're supposed to find. So you go to stat, right? Edit. Press enter. Right, so on your calculators, go to stat, and then edit, enter, and you get this. And you need to fill all of these bad boys in, all those numbers into your list one. All right, so fill them all in. Now, again, so you get used to this. Pause the video, type the stuff in. I'm going to be moving much faster through this, okay, so I can fill more in one video than what you should be doing anyway, but just pause the video, fill this all in. So the point is, you fill your stuff into L1, right? Got it in my list. Go to Zoom Stat, which is Zoom 9, and you can view to see what it looks like. And this is what mine looks like. Okay? There you go. That's what it looks like. Now, that's how it would show up on your calculator, right? It looks like a majority of them are happening there and not so much anywhere else, which, okay, and that's what we said. Doesn't look normal at all. It looks like it's kind of fading down as it goes, right? So now if we were to do it by hand, what would it look like? All right, the horizontal axis would be the classes, and you got to label them. The vertical axis would be the frequencies. Again, got to label them. The bars must be equal distant. All right, so as I'm looking at this, here was my graph by fours every time, like I said to put, right? I have it labeled by ages, my frequencies. If you were to do this by hand, this is what you would have to do to show them. By hand what you were doing. You gotta label them. All right, so when you're taking the AP exam, yeah, you're allowed to use the calculator all the time, but you're still gonna have to copy things over by hand. Okay, so you're gonna have to understand how to make these either way on your own, and there is the frequency distribution of it. Now you can see a little better that it kind of comes down just like that. Again, we should not have our boundaries as the endpoints, right? 18 and 44 were not my boundaries for my endpoints. I had a 17.5, and I forget how high it went. 49.5, definitely not my bounds. We do not want to miss anyone's hair color by doing it. So if we went from 18 to 21 and then 22 to 25, there might be somebody right in the middle, right? We would miss people between 21 and 22. All right, we could also do a histogram with the relative frequency. On the graphing calculator, just plug in the percents instead of the counts, right? Plug in the percents instead of the counts. So if I plugged in the percents of each one in there instead, right, we would get the same looking graph on the calculator. Okay, same exact one. All right, same idea, same shapes. You wouldn't even have to put the counts. You could put the percents in there. That's basically what I'm trying to show you. The same would happen with our histogram by hand, right? If I was to do this by hand, this is still ages by hand, still going over the same amount. The frequency now as percents the whole way up, it still looks the same, okay? So whether I did it with counts or whether I did it with a percent, all right, it's not going to make a difference. Notice the shape is still the same. If we did a graph of the cumulative frequency, all right, it would help us see the growth of the data. All right, and on the graphing calculator, the cumulative frequency, right, would be this. If I plug them all in, right, that's the cumulative frequency on the graph. And this is what shows up in my graphing calculator. So it's kind of like, looks like we got to jump here. What's going on? By hand, though, right, if we were to look at our graph by hand, every 4, right, this is what it would be. It looks like it kind of is shooting up right away and then just kind of levels off. Is basically what it looks like is happening there, right? So it starts off with a big jump, and then the jumps are much smaller as we go. So let's now discuss ways to organize the data. And there are a variety of ways for us to organize this data, right? We can organize data into tables. but the different figures and bars we create can sometimes be spiritless. All right. So sometimes when we create things, it's hard to look at them with graphs and charts, right? Some types of graphical displays are often best for seeing patterns. So sometimes if we graph something, you might be able to see visually a little clearer what's happening with your data. All right, and these patterns can represent and be present in immediate impressions of what you have. And some of the most common visual representations of data that we have, the best visual ones, are dot plots, literally exactly what it says, just dots in a row, straight up or straight across. Bar charts, same, just bars going straight up, down. You just saw a histogram, also a bar, and then stem and leaf plots as well. And it's very important to understand that all graphical displays should be clearly labeled, leaving no doubt in the picture. That's huge. All right? You gotta have everything labeled. You gotta have the axes all labeled. They gotta know the spacing in between each one. All right? That is very key when doing these graphs. AP stat scoring guidelines will penalize you for the lack of titles and labels. Okay? No doubt they will. Make sure everything is labeled. So here's a tip. The first thing to do with data is to draw a picture. Always. You want to draw a picture. All right? You want to do that. So let's start with some bar charts, right? Bar charts are useful when we're talking about categorical variables. All right? Different books use different words, right? Categorical or qualitative variables, depending on how a book wants to refer to them, category or qualitative. Categorical or qualitative variables are variables that note the category for individuals belonging. Okay, category. This is different than quantitative variables. All right, quantitative variables and qualitative are different. Quantitative variables take on numerical values. So here's another tip for you. All right, and these tips are crucial in helping you with your AP exam, right? Graphs must have appropriate labeling and scaling, or you're going to lose credit. Okay, you just will, or you're going to lose credit. Another tip: just because a variable has a numerical value doesn't mean it's quantitative, because that's what ends up happening. Everyone sees numbers, they instantly jump the gun and say it's a quantity. Numbers are quantities, so therefore it's quantitative. Not all the time. All right, lots of times it is, but not all the time. Okay, so take a look at an example here. All right, and again, pause the video, write the example down. That's all you got to do. Okay, just pause the video, write the example down. In a survey taken during the first week of January 2017, 1,100 parents wanted to keep the school year to the current 180 days. 300 wanted to shorten it to 160, and 500 wanted to extend it to 200, and 100 expressed no opinion. Okay, so you're reading this, and we're trying to figure out a couple things. So it does look like a majority wanted to keep the school year the current status quo. All right, and then some wanted to extend it, and others, right, wanted to shorten it, about the same difference in between. All right, and then 100 expressed no opinion, because there are always people who don't really seem to care. Note: 2,000 parents were surveyed. Right, add those puppies all up. Right, add them all up. 2,000 parents were surveyed, so percentages can be calculated now. And here's a picture of their graph. This is a bar graph. Why? It's bars, and they aren't connected. If they were connected, probably end up being some kind of histogram. So it's the number of parents that are saying their opinions for each one. Okay, 180 days. I get it. It's a number, right? Doesn't mean it's quantitative. Okay? It's the number of days that we're talking about. Desired length of school labeled, number of parents labeled, right? I'm finding the percentages now using the calculator. Basically, in the calculator, this is what I typed in with the 11. This is what I typed in with the 300. This is what I typed in with the 500. This is what I typed in with 100, right? This is what I typed in to get the percentages. That's all I did. So now I know the percents of each one. So if I look at a dot plot of each, dot plots can be used with categorical or quantitative variables. Categorical or qualitative and quantitative variables. So look at this example now. All right, so that was just to show you. The last one was just, hey, take a look at a bar chart of the data, right? Got a bar chart. Sweet. Next up, this one. When asked to choose their favorite hip-hop artists, 8 students chose Eminem, 5 picked Tupac, 6 picked Biggie, 3 picked Nas, 5 picked Dr. Dre, 3 picked Jay-Z. All right, so they got it, right? These data can be displayed like this, and this is a dot plot. Okay, a simple dot plot, just the number of dots who liked who is basically where it's at. Okay, so just have them spaced out like dot plots. That's all it is. There you go. All right, here's another example for dot plots. The dot plot below shows the length of stay in days for patients admitted to a rural hospital during the first week in January 2017. So, all right, this is their length of stay. Now, notice how it's 0 to 5, and there's a whole bunch in between there. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So you can see it does actually mean each difference, each day. They just don't have a marker down for each one. So it is number of days, and it looks like mostly everyone is starting off closer to this hunk right here. And then once we get down to around 9 to 10 days, that's when things start to dwindle down, because it makes sense. It's probably more serious. So most people are in between this era right here, right? It looks like if you were to count up all these dots, it looks like most of them are probably from around here down, right? We have histograms, which we already went over, and I will actually pause the video right here so that when we come back we can dive in with histograms and take a look deeper into them, but showing you all the different graphical displays of things.